Hello friends, welcome to this section. In this video, we shall be looking at how to fill electrons in orbitals. In previous videos, I described how you can fill electrons in orbitals using this format. If you watch my previous videos, you are going to realize that we have 1s, 2s down to 7p. I explained each of these processes. So today we shall be using it to fill basically two elements. Two elements, we have aluminium and that of chlorine. Now, from Aufbau principle, it simply states that electrons will fill the lowest energy before moving to a higher energy. In this case, 1s is of a lower energy than 2s. So it means the filling begins with 1s, 2s, 2p, 3s, 3p, 4s down till we get to 7p. So a good knowledge of this will help you to solve such a problem. So in the first case solution, we have aluminium. Aluminium is having the symbol Al, having atomic number 17 and mass number 27. Our sole focus is on the atomic number, which is 13. So let's get started. In writing the electronic configuration of aluminium, the first shell, which is the S orbital, we have S, P, D, and F. S signifies sharp, P is for principal, D is for diffuse, and F is for fundamental. The S orbital holds a maximum of 2 electrons and is spherical in shape. The p orbital holds a maximum of 6 electrons and it has a dumbbell shape or a marked unidirectional character. The d orbital is more of like a double dumbbell shape, of which it has a complex nature, but it holds a maximum of 10 electrons, and then F is a more complex orbital which holds a maximum of 14 electrons. So for the first case, according to Aufbau principle, we are beginning with 1s. So we have for aluminium 1s, and s is having maximum 2 electrons, so we have 1s2. We have 2s, s holds maximum of 2 electrons, so 4 is gone out of 13. The next energy is 2p. So 2p, p holds a maximum of 6 electrons. So 2, 4 plus 6 is 10. 10 is gone out of 13. The next orbital will be 3s. 3s is supposed to hold a maximum of 2 electrons. So we have 3s2. Now when you add all of these, you are going to realize this is 8, 10, 12. 12 electrons are gone, remaining 1. So where will the 1 electron go to? After 3s, it will go to the 3p orbital. So the remaining 1 will go to the 3p orbital. So we have it as 3p1. In all, we have been able to write the electronic configuration of aluminium as an element. So aluminium represents 1s2, 2s2, 2p6, 3s2, and 3p1. On to the second example, we shall be considering chlorine in this case. Chlorine is having symbol Cl, atomic number 17, and mass number 35.5. But as I stated earlier, we shall be focusing more on the atomic number to write the electronic configuration. So let's get started. From lowest energy level, we have 1s2, 2s2, 2p6, 3s2. Now let's count. This is 6, 8, 10, 12. 12 electrons gone out of 17, meaning we are left with 5. So we're left with 5. So after 3s, we have 3p. And p holds a maximum of 6, remember? So the remaining 5 will go to the 3p orbital. So we have this as 3p5. This is how to write the electronic configuration of an element such as chlorine. So adding all, we have this is 10, 12, and then plus 5 gives us a 17. Now considering the orbital diagram, let us also draw the orbital diagram for both cases. So for the orbital diagram, in the first case, we have aluminium with atomic number 13. For 1s holds maximum of 2, so one spins up, the other spins down. 1s2, so this is for 1s. 2s holds maximum of 2, one spins up, the other spins down. This is for 2s. The next is 2p6. So p orbital will have p, x, y, and z holding maximum of 6 electrons. So according to Hund's rule, electrons will be filled singly first before pairing. So this is how we fill 2p6. 1, 2, 3, then we pair 4, 5, and 6. So this represents 2p. The next higher energy is the 3s, and s is having just 2 electrons. So we have 2, 1, 2. This is for 3s, and then we have 3p. P is having 6 x, y, and z, 2 pairs. So in this case, we have just 1, so it goes into the first. So this is for 3p. What we have done, we have drawn the orbital diagram for aluminium. Onto the second element, which is chlorine. Chlorine atomic number 17. So let's draw the orbital diagram. We have 1s2. One spins up, the other spins down. For 1s, lowest energy. For 2s, we have 2 electrons for 2s. This is for 2s. We have for 2p, p occupies 6 electrons, x, y, and z. So from Ampere principle, we fill each electron singly first before pairing takes place. So this is for 3p. The next is 3s. S holds maximum of 2 electrons, one spins up, the other spins down. The next is 3p5. P, remember, is having 6 electrons maximum for x, y, and z. Now, according to alpha principle, we have 5 electrons, so the filling goes this way: 1, 2, 3, 4, we pair, and then 5. So what we have done so far is we have drawn the orbital diagram for chlorine. We have for aluminium and we have for chlorine. The same method can be replicated for every element of the periodic table. I'm sure this video is helpful to someone. If you are new to this channel, do well to subscribe, and to my returning subscribers, I will always say thank you for showing up. See you next time. Bye for now.